Part 7. Graphing and Inverses. You will need to know how to use Desmos graphing software to follow along with the examples given here. If you don't know how to use Desmos for graphing, please check out that video in my playlist, or go to any other Desmos instructional video. As mentioned previously, mathematics is a language like any other. It has an alphabet, a vocabulary, and grammar. You will now be shown how to translate logs into a dialect that I facetiously call XY speak. It is what you need to know in order to graph. When you are working with functions, there are certain restrictive parameters. Otherwise, the equation is not a function. It is just an equation. For example, the input and output instances must be unique to each other. So, we have defined what y and x stand for in a general way. But what is this? It signifies several things. That the value of y depends upon the value of x. That a little routine may be performed upon the x values as they are fed through a little machine. A routine defined by the rule. Personally, I prefer to think of it as an operator, one that signifies, at least, all of the above. An operator, like the plus sign for instance, signifies performing certain mathematical operations upon a number or numbers. Translating this notation into plain English. Any instance of the output set will be a unique result of a thing done to any allowed instance of the input set, according to some specification or relationship definition, which is not always given. A function definition can be ad hoc or part of a closed and highly defined system like logs and trig. If you are familiar with trig, you will recognize sine as an operator that instructs you to use the ratio of two specific triangle legs to one another. The antilogarithm function instructs you to raise a base to a logarithm. The logarithm function instructs you to look up a log value that corresponds to a given antilogarithm. Here is a comparison of general function notation to that for logs and antilogs. So, how do we translate all of the above into XY speak to make it suitable for graphing? Notice that, on the one hand, the output is L and the input is A, and, on the other hand, the output is A and the input is L. Each of these two equations needs to be expressed in XY terms because, conventionally, input items are designated along the horizontal X axis and output items are measured along the vertical Y axis. Assign X and Y symbols to these equations. Open Desmos and enter the log functions for bases 2, e, and 10. Pause the video. Once you are satisfied with your work, make those three function lines invisible. Now enter the three exponential functions, 2, e, and 10, to the x. Pause the video. When you are satisfied that you have done this correctly, make all of the function lines visible. Notice the symmetry about a diagonal line that would pass through the origin. In fact, the functional equation for such a line is y equals x. The symmetry of the log and antilog graphs about the y equals x line is the graphical, visible, expression of inverseness. In the next video, I'll discuss some of the finer points of the notation and algebra for inverses, especially with reference to using xy notation.